Hello, good evening. Uh, this is for Arduino programmer out there. So I have created a new library for socket. So actually, I need this library for one of my application on my IoT library, which I need to have a socket server that can communicate with the other devices. But unfortunately, when I look for the built-in library within the Arduino, I cannot find the perfect one that will suit for my requirement. So I just decided to create myself from the scratch using the core library from the ESP, which is the TCP.h. So I will be utilizing all the socket available interface, API interface that we can use for this application so that we can generate our own socket programming. So the idea of this socket is exactly similar to what we have in Windows socket. So if you are familiar with that and you work closely with that kind of socket, it will be exactly similar with that library. So I will expose exactly the function that we are needing for this application, as well as the callback function that is available for us in order to develop a function associated with the sockets. So the most familiar one is the chat system, where you have a server and you have a client. So for my case, I will be using one of my microcontroller, the server, and it will be hosting several client or several third-party devices that can communicate in the socket. Um, like for instance, PuTTY. So if you want to go and configure the device using PuTTY, you can use it as well. There are a bunch of applications. You can also use like Modbus on TCP socket and other socket application. You will be this will be useful for your future use case. Okay, so let's start describing the library that I have created right now. So this library is 60% done. Roughly, it can function according to the basic socket, but it will require fine tuning for crashing and making it fully functional socket. But right now I have managed to develop the basic function of the socket client server application. So let's start with the first main class, which is the socket itself. So right now I just expose the setup server, start server, and loop. So actually I found out that the API that is available on TCP is you don't need to have a loop. It's becoming like asynchronous. So I will be removing this one um, in the future. So okay, the next one is the server, which I am using here as a private, and I'll be using this one to start the server. But eventually I will create also the client socket so that I can use this library for both client and server application. So this is the class template and the class declaration for the socket itself. So if you look at on the main where I'm using this library, so I will import that one, and then you will just instantiate the name of the socket, and then this is how you're gonna start set up server. So this is your port, and then once you set up the server, you can start the server. So what is going on inside, we will explain that one by one. So first I will explain first the three classes that is involved into this one. So this is the server. So the server will be listening to the connection from the remote client um, according to the port that you define on the setup server. So the only significant events that we are going to look at from the TCP is the accept event. So when there's a new connection, it will accept the connection, and then um, we're gonna pass it to the client. So this is the one that will manage all the client transaction, like sending, receiving, you handle the close connection, error, etc. So what we have over here, so on top of that, I also going to expose all the events inside of this client information to the parent calling class that is calling this client info for future use, so that we can see what are the exchange of information that is being sent from the client to the server without going into this class anymore. So we'll be like bring this one until to the main, so that you can do your own handle her for all the socket events. Okay, so these are the description. And okay, for the socket is eventually okay, basically it's just a very basic one, so it's just still empty application. So for the socket we will define the constructor, and then we're gonna, once you call the setup server, you will call the listening port, you assign the listening port, which is the private variable, and then you call the setup of the server itself, and then from there the server will be listening at that port. So on the server side, so we have the start stop. As what I have said, loop, we don't need that one in the near future, because this will be running in the asynchronous mode without any loop. We will be just using the pooling, which is built in from the TCP library. Okay, so this is the server. So server is a little bit busier. There's a lot of code inside, especially for the start. So on the start is where we're gonna define the socket, the listening socket. So this is the bunch of code. So you're gonna bind the IP address. Once you bind, then you're listening to that port successfully. And then for the backlog, you can have only 5 clients available. So you can have more, but it depends on how much is the capacity of your microcontroller. Like for my case, I'm using 8266, so the memory is very very small, so 5 should be more than enough. So with this bunch of code, the most important thing is the TCP accept. So this is where you accept the connection from the remote client. So the TCP accept, there's a lambda function, which is you need to, whenever there's a new connection, this will be the handler that will accept that one. And then since this is static function, which is this one, and you need to link this one to your class library, so you need to, the argument, which is the
Sorry, something's not right.
which
Wait a
is
few minutes and try setting up again. You can also try unplugging your device and plugging it back in.
okay, so that's an interruption anyway. So yeah, so from the static function, so you just call this reinterpret from this pointer, and then you call the internal function within the class itself. It's weird, I never used to do this one, but this is the only way for you um, to access the lambda function from the TCP API available functions for sockets. So this is not magic. I just look at the um, existing configuration, that the built-in function that we get in Arduino, and this is how they use it. So I just copy this approach over here. Anyway, so once you have a new client, the accept function will be called, and then from here you're gonna instantiate your new client right now, which is the one handling all the transaction to the remote client itself. So just take note that this will consume a lot of memory, and if you are using your stock memory, you'll be run out of memory for that. And especially if you are handling 5 simultaneous connection, so stock for sure will be stock overflow. So we need to save that one on the hips, so that's why I created a new over here. And then eventually after that one, I should create another uh, line of code over here that we need to add this one in the linked list, vectors, or whatever kind of array that you use for handling with the with the pointers. But probably we'll be using the linked list over here. Okay, so as what I have discussed a while ago in the client info, we have a bunch of events over here. But right now, what I'm going to test is the receive function that I'm passing it to the server class. So this, once you have the receive, this will be the one handling it. So once we run this one, if we send any text or any string from the remote client, we should be able to receive from this function itself. So eventually I will send this one from the server to the socket and eventually to the main, so that whoever will use this library, they can use all those events, and they can create their own socket application like microcontroller on the group chat. Okay, so let's compile and download to the microcontroller. If you're asking why I'm using Visual Studio Code, uh, Arduino IDE is not that intelligent that it will give you the IntelliSense. So IntelliSense will make your life easier, and it will also correct if there's a syntax error or whatever. So it will be for productivity and easier for you to look at where you have some error in your code, and you don't need to worry about the syntax anymore because Visual Studio Code will take care for you. And the most important thing is the IntelliSense. Okay, so it's running, it's connected to the Wi-Fi, and it's listening at port 5000. Okay, listening socket created successfully, bind, and then set up with backlog is listening at port 5000. Okay, so we'll be using PuTTY as our client. I already saved the IP 10058, and in the port 5000 I'll be using row so that I can send a text. Okay, just take a look below when I create the connection. So new client, which is this one, accepted, and start pulling. And so on the server itself, once you have the in the client info, once you have the new client connection, it will send the hello world, just the acknowledgement, that just to test the exchange of data basically. So I received the word hello world, and let me try to send any string coming from PuTTY. This is from PuTTY. Okay, I received the thing over there. This is from PuTTY. This is again another string from PuTTY dot 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 dot. Okay, so the exchange of data from the client to the server is working fine, and I have the basic socket right now basically. So basic socket application, this library is really capable to do it, but there are a lot of things that need to be done before I'm going to publish this one in public. So first thing first is when I'm going to handle the on receive function, on the receive events, so I need to take care about the packet which is big that I am going to receive. So I need to chunk that packet and then receive it piece by piece and assemble it in the on the buffer or whatever. At the same time, on the send function, I also need to do the chunks and data. So those are the two things that I need to take care inside the client info. And then on the server side, I need to create my array, and those array will be taking care if the connection will be closed, it should clean up the pointer of those connection, so that it will free your hips. Otherwise, you'll be having a lot of memory leak. Okay, hopefully this will be useful for everyone that will be going to use this one in the future. And if you're interested to uh, contribute in this library, you are welcome. You're welcome to give your contribution. Okay, thank you.